Now your last module, module 6, right? That is based on diode and rectifier. So one of the numerical will definitely come for the rectifier. Okay. So as you know, rectifier is divided further into two categories. One, the half wave rectifier, and another one is the full wave rectifier. Correct? In the half wave rectifier, the diagram is like this. We'll have single diode, we'll have transformer, and then we'll have load connected, something like this. And in the full wave, it is further divided into category. One is the center tap rectifier, another one is the bridge type rectifier. So center tap rectifier, like first transformer है, then we'll use two diodes and one diode in the middle. Why in the middle? Because they said center tapping. Like if suppose we'll have 4 number of turns, so 2 number of turns ऊपर, 2 number of turns नीचे, equal. Bridge type rectifier is just like a Wheatstone bridge. Wheatstone bridge इस type से होता है ना. Must know the diagram. एक इससे connect है और एक इससे, and in between load is connected. Okay, ये theory वाला part है. Now come to the numerical. I am drawing one table for you in which there are all the formulas related to the rectifier for both half wave and full wave. Okay, so one will consider for the half wave rectifier, then for the full wave. In the full wave we'll have center tap and we'll have bridge type rectifier. Correct? So now see, now tell me, in number of diodes, the half wave rectifier is how much? Tell me. 1 in the center tap, 2, and in the bridge type, 4. Now the formula for the IDC, or we can say I average value of current. Okay, now can you tell me what is the formula for the half wave rectifier? That is I max divided by pi. I max is the maximum current. For the center tap, it is 2 I max by pi. Again for the bridge type, it is 2 I max by pi. Okay. Now suppose if we want to calculate IRMS, IRMS is root square, would be I max by 2 only for the half wave, I max by root 2 for center tap, I max by root 2 for bridge type. Okay. Next one is PIV. PIV inverse voltage. So it for half wave rectifier it is Vs maximum. For center tap it is 2 Vs maximum, and for bridge type also it is Vs maximum. Why in center type it is different? Because कि वो center tapping होती है ना, तो double होता है, ऊपर की Vs max and नीचे की max, it will become 2 Vs max. Okay. Now if they ask you to calculate VDC or average, then in that case the formula is of VDC is equal to IDC to RL, right? IDC value we already know, that is I max by pi. So I max by pi into RL. Similarly, this one also become 2 I max by pi into RL, and this one also 2 I max by pi RL. Got it? Clear this thing? Now now next more formulas are left similar to this. Again for the half wave rectifier, HWR, full wave rectifier in center tap, and this one is bridge type. So if they are asking the rectification efficiency, okay, so rectification efficiency formula is for the half wave 0.406 divided by 1 plus RF by RL. For this one it would be 0.812, 1 plus 2RF by RL would be 0.812 divided by 1 plus 2RF by RL. Okay, if suppose RF means the diode resistance is not given, then we need to consider 0, because if they have not given, then we need to consider 0, right? Then in that case efficiency would be 40.6%, 81.2%, 1.2%. Okay, now the next formula, form factor, that is IRMS divided by IC. Okay, its formula is fixed. So if I want to calculate IRMS, IRMS is Imax by 2, IDC is how much? Imax by pi, correct? So Imax cancel, it would be pi by 2, that will be 1.57. Same formula for the center tap and bridge type. It is what? Like IRMS by IDC. IRMS is how much? Imax by 2, and IDC how much? As you know, IDC is 2 Imax by pi. Okay, so Imax would be cancelled out, then you will get the further value. Okay, now the next formula is, similarly they can ask you the peak factor. Peak factor is denoted by Kp for HWR, for center tap, and for bridge type. Kp formula is max divided by Vrms. So Vmax is how much? Vrms is how much? Vmax by 2, right? So it would be cancelled out. Answer is, in this case also Vrms is how much? Vmax by root 2. In this case answer would be okay. Now they ask you the output frequency. Output frequency for half wave rectifier it is same, but for full wave it is 2f. 2f means twice of the input frequency. Next, last but not least, transformer utilization factor. They can ask you, and its formula is 0.286 multiplied by RL divided by RL plus RF. Similarly for this one it would be 8 by pi square, 1 divided by 1 plus RF by RL. See, in this question they said half wave diode rectifier. Okay, voltage drop across the diode is 0.7 volt, load resistance is 600 ohm, RL is equal to 600 ohm. The RMS value of the input means Vrms is equal to 28.87. So you need to calculate IDC. If we know the value of Vrms, can we get Vmax? That you know now, Vrms is equal to max divided by 2 for the center tap. Now you know Vmax is equal to Imax into RL, right? According to Ohm's law, V is equal to I into R. Vmax you know, RL you know. Can you get Imax? If you get Imax, IDC is how much? 2 Imax by pi, right? IDC or I average is same. Sorry, for the half wave it is Imax by pi for the half wave. So we can get IDC, we can get IRMS. If we know IDC, we know IMX, then we get IRMS. Imax by 2 is equal to IRMS. Next they are asking PIV. PIV is peak inverse voltage, that is Vs maximum. So if V maximum is only the Vs maximum. Okay. And then they are asking the form factor. Form factor formula is IRMS by IDC. We already calculated IRMS and IDC. We can get the form factor, right? So you will get these kinds of question in your paper.